Building on that foundation, setting clear expectations for security by design establishes the baseline for all suppliers and developers. Security by design means addressing threats in architecture, code, and operations before they appear in production. Contracts and requirements should call out secure defaults, least privilege, and data protection from the first line of code. For example, a system design that enforces encryption, segmentation, and input validation from day one will prevent entire classes of future defects. Expectations must be measurable. Design reviews, security testing plans, and certification milestones all become deliverables. Stating these standards up front ensures everyone, from procurement to developers, knows that security is a non-negotiable quality attribute. Continuing the engineering thread, secure development lifecycle requirements formalize how security is woven into creation and maintenance. A secure development lifecycle, often shortened to SDLC, prescribes checkpoints, requirements review, static analysis, code inspection, dependency scanning, and pre-release penetration testing. The contract should specify which SDLC framework suppliers follow, what evidence they provide, and how issues are tracked to closure. For instance, quarterly secure coding training for developers and tool-generated scan reports may form part of the deliverables. An enforced SDLC ensures that risk reduction becomes a process, not a one-time promise. Building on integrity assurance, component authenticity, and supply tracing, guard against counterfeit or malicious parts entering the environment. Each hardware or software component must come from a trusted source, verified through digital signatures, traceable bills of materials, or vendor attestations. Supply chain attacks often begin with small substitutions that evade attention. Imagine a network appliance shipped with unverified firmware. Tracing its origin after compromise becomes impossible without records. Requiring a software bill of materials, or SBOM, and supplier authenticity documentation lets organizations confirm lineage. Authentic components form the first layer of trust for every subsequent control. From there, third-party component risk governance addresses the growing reliance on external libraries and services within delivered systems. Modern applications rarely build everything from scratch. They depend on frameworks and open-source packages that carry their own vulnerabilities. Governance requires that suppliers maintain an updated inventory of all external components, track known vulnerabilities, and document how patches will be applied. For example, a vendor using an open-source encryption library should disclose its version and patch cadence. Visibility creates accountability, and accountability creates resilience. Without governance, hidden dependencies become silent liabilities. Building further, penetration testing and remediation obligations provide external validation that safeguards perform as promised. Contracts should specify testing frequency, scope, and independence. Testing must include both application and infrastructure layers, with clear rules of engagement to avoid operational impact. Most importantly, the supplier must commit to timely remediation and retesting until findings close. For example, critical issues might require resolution within 30 days, verified by a new test report. Continuous validation converts static assurance into ongoing confidence. Systems tested, fixed, and retested live longer and safer. From there, vulnerability disclosure and patch timeline requirements keep transparency and responsiveness predictable. A responsible disclosure process defines how suppliers report vulnerabilities they find or receive, how quickly they notify customers, and how updates are distributed. For instance, a vendor might pledge notification within 72 hours of confirmation and patch release within 30 days. These timelines turn uncertainty into expectation. Public disclosure coordination prevents panic and promotes trust. Organizations that manage disclosure professionally demonstrate maturity to regulators and clients alike. Continuing with configuration assurance, secure configuration and hardening baselines ensure that systems arrive in defensible shape. A secure baseline defines which services, ports, and settings are enabled by default. Suppliers should provide configuration guides aligned with industry standards and, when possible, automated scripts to enforce them. For example, a hardened operating image might disable unused network services, apply strong password policies, and enforce audit logging. Delivery should include baseline verification evidence. When every new system starts secure, Administrators spend their time maintaining strength rather than cleaning up weak defaults. Building on operational continuity, suppliers must also commit to logging and monitoring integration. Systems should generate logs that capture security-relevant events, authentication, privilege changes, configuration edits, and export them to the customer's monitoring platform. Evidence of log schema, retention, and alerting thresholds should be included in design documentation. For example, a vendor-supplied application could forward audit logs to a centralized SIM within 5 minutes of generation. Logging is the nervous system of security. Acquisition that omits it leaves the organization blind to its new environment's behavior. From there, service-level objectives for security convert intent into measurable outcomes. These objectives define acceptable performance for patch timeliness, incident response, or system availability under attack. For example, a supplier might commit to resolving high-severity vulnerabilities within defined hours, or maintaining 99% uptime of security monitoring feeds. Tracking these objectives alongside functional metrics reinforces that security is a deliverable, not decoration. Over time, trend data reveals whether partners improve, stagnate, or regress. Reliable service levels build long-term confidence. Building on that accountability, acceptance gates before production go-live ensure that no system enters service without passing defined assurance checks. Acceptance criteria should verify documentation completeness, test results, resolved vulnerabilities, and configuration baselines. A joint review board can approve or delay deployment based on these results. For example, a system might not proceed until its penetration test shows 0 critical findings and its certificate management integration is confirmed. Acceptance gates formalize quality control, turning readiness into a factual statement rather than a hopeful launch date. In closing, engineered assurance and accountable suppliers create systems that earn trust rather than assume it. When acquisition embeds security into design, testing, and verification, the result is resilience built by requirement rather than retrofit. Threat modeling, documented baselines, patch discipline, and measurable service levels together form a chain of confidence. Each link, design, build, test, deliver, carries its own proof of integrity. Mature acquisition programs treat these proofs as integral to performance, not optional extras. The outcome is a portfolio of systems that arrive secure, stay secure, and prove it throughout their operational life. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.